Now let's look at the second problem on slide 11. So in this scenario, we have an apple in a tree. It weighs 1/2 kilogram. It's a pretty big apple. It falls down, and right before it hits the ground is going 12 meters per second. We want to figure out how high up in the tree was it to begin with. So we know that in the before scenario, it wasn't moving, therefore it only had potential energy. But if I set that up, here's what happens. So I have my potential energy. I know my mass is 0.5 kilograms. I know gravity is 9.8 meters per second squared, but I do not know my height. Okay, I have two unknown variables in this scenario, so I can't solve this problem yet. So I need to work backwards. I need to work from the ending. So after, I know that it has all kinetic energy. Okay, it's right before it hits the ground, so we're going to assume there's no potential energy there. And I know that that is 1/2 mv squared. If I plug this in, I know 1/2. I know my apple is also 1/2 kilogram. And then I know my velocity is 12 meters per second. When I plug all of this into my calculator, I get 36 joules. So the kinetic energy that it had at the end was 36 joules, which means that the potential energy that it had at the start had to be 36 joules as well. So now I can come up here and set all of this equal to 36 joules. Plug in all of my numbers. Divide both sides. I think I'm going to run out of room. And you end up with, let's see, we'll go over here. You end up with a height that is equal to 7.35-ish meters.